Hello, engineers. Hope you all are doing great. In our last video, we discussed scalability when we had a discussion around horizontal scaling. During our discussion, we introduced something called load balancer. In this video or upcoming set of videos, we shall be discussing about load balancing and about load balancing techniques or algorithms. Also, in upcoming set of videos, we shall be having on hands-on over the load balancing. Shall be implementing load balancers using Nginx and also elastic load balancers provided by AWS. So let's start. तो देखते हैं लोड बैलेंसर्स होता क्या है. सपोज एक सिनेरियो कंसीडर करते हैं. फॉर एग्जांपल एनी सिनेरियो. अगर मेरा कोई स्टार्टअप है, सपोज आई एम हैविंग अ स्टार्टअप और उसका पीक टाइम चल रहा है. पीक टाइम चल रहा है, सपोज आई एम हैविंग अ कैब सर्विस प्रोवाइडर लाइक ओला और उबर. ओके, उसका पीक टाइम चल रहा है, पीक ऑफिस आवर्स चल रहे हैं और इट्स ग्लोबल. वो दुनिया के हर कोने पे है. और आई एम गेटिंग समवेयर अराउंड 10 मिलियन रिक्वेस्ट पर सेकंड. 10 मिलियन रिक्वेस्ट पर सेकंड ग्लोबली. ओके, अब होगा क्या if I have a normal client server architecture. Let me draw it here. Sorry, client raises a request to server and server processes it and responds back to the client. Responds back to the client. ठीक है. अब इशू इस आर्किटेक्चर के साथ क्या है ना, इस आर्किटेक्चर के साथ क्या है कि दिस सर्वर might not be capable of handling 10 million requests per second. This might not be capable of handling 10 million requests per second. तो इस सिनेरियो में मेरे को क्या करना होगा. One option is vertical scaling, as we discussed in our last video. But we had some challenges with vertical scaling. Another option we had was introducing multiple servers, and that we called horizontal scaling. दूसरा मेरे पास सिनेरियो है कि मैं मल्टीपल सर्वर्स इंट्रोड्यूस कर दूं. तो हम वही वाला सिनेरियो कंसीडर करते हैं. लेट मी इरेज दिस ऑल फॉर अ while and let me draw a good server here. Suppose this is my server A. This is my server A, and let's we have three more servers of such kind. This is server A, this is server B, then we have server C, and then we have server D, and we have client here. We have client here. This is our client. This is our client machine. Color भी कर देता हूँ इसमें मैं. This is red, let's say, and these all servers are green. अब issue क्या है कि I can connect only single server to my client. Either I can connect this server A, I can connect my client to server B or to server C or to server D. But what the problem statement is that I want something to distribute this whole workload, this 10 million per second workload across all these four servers, ठीक है. तो मैं इस केस में क्या कर सकता हूँ. आई नीड समथिंग कॉल्ड लोड बैलेंसर. लेट मी इंट्रोड्यूस द लोड बैलेंसर हेयर. अच्छी सी इंग्लिश में मैं लिख देता हूँ इसका नाम लोड बैलेंसर. ये मेरा लोड बैलेंसर है. अब ठीक है, ये तो हमने बता दिया ये लोड बैलेंसर है. बट वाई व्हाट इज दिस. आखिर ये लोड बैलेंसर है क्या. व्हाई हैव वी इंट्रोड्यूस दिस टू डिजाइन. तो अभी क्लियर करते हैं व्हाट डज इट मीन, व्हाई इज इट रिक्वायर्ड. What is load balancer now? Before understanding load balancer, let's discuss the term load balancing. What is load balancing? Load balancing क्या होता है ना? Like we shall be having multiple requests from multiple clients. Obviously, load balancing is a technique of redirecting the multiple client requests to multiple servers we have. अगर मैं इसकी एक formal definition यहाँ पे लिखना चाहूँ, I can write, I can write, just a minute. I can write it is a method of load balancing. Load balancing is the method of distributing client requests across the pool of servers, the pool of available servers. Like we shall be having multiple requests from multiple clients. Load balancing is a matter of distributing these client requests across the pool of servers. So what is this load balancer? What is this load balancer? Load balancer is a tool which is helpful in load balancing, जिसके थ्रू हम load balancing कर सकते हैं. Now we have introduced this load balancer here. So what we can do, we can connect a client to this load balancer, and this load balancer is smart enough to forward a request across these multiple servers. Now we have different kind of algorithms for this scenario, for these kind of scenarios. लाइक वन कैन बी के मेरे को कुछ ऐसा चाहिए कि सिंगल क्लाइंट की रिक्वेस्ट हर बार सेम सर्वर पे जानी चाहिए, सेम सर्वर पे जानी है. इन वन सिनेरियो आई वांट अ equal distribution. Request one goes to A, then B, then C, then D, then again A. I have different such kind of algorithms. I have different such kind of algorithms. मैं एक बार अच्छे से इसको ड्रॉ कर देता हूँ यहाँ पे. ठीक है, ये तो मेरे को समझ आ गया कि मेरे क्लाइंट की रिक्वेस्ट आ रही होगी लोड बैलेंसर पे और वो इक्वली सर्वर्स पे डिस्ट्रीब्यूट कर देगा. बट व्हाई डू वी नीड इट? इसका बेनिफिट क्या हुआ? इसका बेनिफिट क्या हुआ? बेनिफिट इसका ये हुआ, previously we had only a single server. Previously we had only a single server which will require to handle 10 million requests per second. 10 million requests per second, or let's say 8 for simple calculations. This is 8 million requests per second. Yeah. Now we have four servers. Now we have four servers. अगर मैं आपसे पूछूं कि सिंगल पार्टिकुलर सर्वर, अगर मेरा सिंगल सर्वर कितनी रिक्वेस्ट को टैकल कर रहा होगा इफ आई हैव इक्वल डिस्ट्रीब्यूशन, so it's a simple math. 8 by 2, that is 2 8 by 4, that is 2 million requests per second. See, this server will be handling 2 million requests, and same for this one. Control C, then I have this, I have something same here, and also this will be handling 2 million requests per second. What does it mean? It means that when a single server was not capable of handling 8 million requests per second, I introduced four servers. Now each server will only required to tackle 2 million requests per second. This is scalability is. दिस इज स्केलेबिलिटी यूज. तो इससे क्या फायदा हुआ? इससे फायदा हुआ, इससे बहुत सारे फायदे हुए. ऑल्दो हम डिस्कस कर चुके हैं अपने प्रीवियस सेट ऑफ लेक्चर्स में अवेलेबिलिटी system, or yeah, our system will be highly available. Suppose this server fails, then we still have three other servers to tackle user requests. ठीक है, so our system will be highly available. Our system will be highly available. Then what comes here is scalability. Scalable क्यों है? Like drastic increase हो गया number of users का. Earlier we had 1 million requests per second, let's say. Then we have something कुछ big billion days sale like आ गया, और we now have 8 million requests per second. Now our single server is not capable enough to handle such huge workload. So in that scenario, our system is not scalable enough. But when we introduce more servers, then it becomes scalable. It is capable of handling gradual or drastic increase of user load, workload. Okay. Then we have something called fault tolerance. Fault tolerance. Okay, why the system is fault tolerant? Suppose a single server fails. When we have another three servers to tackle user requests. Unlike in vertical scaling, we had only single server. If it fails, then the whole system will go down, will go crash. So it was single point of failure. But in this scenario, if single server fails, then we have another set of servers to tackle the user request. So these are some of the benefits of introducing load balancer. Okay. Now you will ask me, now how, like what are the scenarios, like what are the rules through which this load balancer redirects the user request to different servers. So I'll say we have different kind of load balancing algorithms. So now we shall be discussing about load balancing algorithms. Load balancing algorithms. Okay. What do you guys understand by load balancing algorithms? See, load balancing algorithms are nothing but set of rules that a load balancer follow to determine the best server for each of the client requests. For each of the client requests. Suppose this is client request, and the set of rules the load balancer follow to redirect it to the appropriate server is the load balancing algorithm. Is the load balancing algorithm. So we can classify load balancing algorithms into two major kinds. Two major kinds. Firstly, we have static algorithms, and then we have something called dynamic algorithms. We have something called dynamic algorithms. Firstly, we shall be discussing about static algorithms. What are static algorithms? See, static algorithms are those algorithms which are fixed. Like eh, these are fixed set of rules. If like whatever needs to be done. It is not dynamic in nature, kind of. Uh, Let me first explore the types of static algorithms, then it will be much more easier for you to understand static algorithms. So, one kind of static algorithm is round robin. This you might have ever heard of during your graduation in the operating systems. This is round robin. Then we have another algorithm called weighted round robin. Weighted round robin. We have weighted round robin. Weighted round robin. And we have another algorithm which is IP hash. Which is IP hash. So let's discuss the round robin first. Let's discuss the round robin first. Let me write it here. It's round robin. Round robin is the simplest kind of load balancing algorithm we can have. We can have. Let's discuss it in layman terms. Suppose we have three servers. We have three servers, or I can copy it from here. It would be easier for me. Yeah. Suppose this is server A. I have. Then we have server B. Then we have server C. Oh, sorry. This is server C here. Oh, it's not pasting. I don't know why. Control C, and I'm trying to paste it. Yeah, it's pasted this time. This is server A. I have this one as server B, and this is server C. Let me bring the what we say. Let me bring the load balancer quickly. I'm bringing this load balancer here. This is my load balancer. Now, suppose load balancer gets the first request. First request. So in round robin case, what it would do, it would redirect the first request to server A. Then comes the request two. Then request two will be redirected to server B. Then comes the request C. Request C will be redirected to request third will be redirected to server C. Then comes request four. Then request four will be redirected to server A, then server B, and so on. And so on. It will follow a static looping mechanism. One, two, three, here, then four, five, six. And this will keeps going on. Now we have few problems with round robin. We have few problems in round robin. Let's discuss it. Let's discuss it. Suppose the first request went to server A. Then a second request went to server B. Then a third request went to server C. Now the scenario, the first request was quite heavy. The first request was quite heavy, and is still occupied with this request, with that process occupied. While while the request B and C had, those were not that heavy. Now server B is idle and server C is also idle. Now the problem with this approach, with this round robin approach, is suppose fourth request come. Fourth request comes. With round robin algorithm, it should be redirected to server A. It should be redirected to server A. But what we are seeing here, server A is already occupied. Server A is already occupied, and still it will force the request B to tackle by the server A. So this is kind of problem. While server B and C are sitting idle, and A is doing some use processing, still the fourth request will goes to server A. This will increase the workload of server A. So this is a issue with round robin algorithm. Then comes the second in the list, that is weighted round robin. That is weighted round robin. Let me write it quickly. Weighted round robin. Oh, weighted round robin. Again, a spelling mistake from me. Apologies for it. What we do in weighted round robin, uh, it might happen that all our servers are not of same capabilities, are not of same capabilities. Server A, let's has 16 cores. Server B, let's has 8 cores, and server C has 4 cores. Do you actually think that requests should be equally distributed among them? I don't think so. Server A is capable of tackling more number of requests than server B and far more requests than server C. So in weighted round robin, we assign a weight to each of our servers. We assign a weight to each of our servers. Suppose we assign a weight 4 to this, or I can write it here only. I assign a weight 4 to it. I assign a weight 2 to it, and I assigned weight 1 to it. Now, in weighted round robin, how the requests will be forwarded across these three servers. Suppose I get request 1, it will be forwarded to A, request 2 to A, 3 to A, 4 to A, then request 5 will be forwarded to B. Then request C will be forwarded, request 6 will be forwarded to B. Then request 7 will be forwarded to C. It will be forwarded in this sequence. Server A will be receiving 4 requests, then 2 requests will be tackled by server B, and 1 request will be tackled by server C. Then again, server A will tackle the 4 more requests, then 2 requests by server B, and a single request by server C. This is what weighted round robin is. This is what weighted round robin is. Let's discuss our last and third static algorithm, that is IP hashing. That is IP hashing. IP hashing. What is done in IP hashing is client will be requesting server from some machine. That machine shall be having some sort of IP some IP address. Suppose this is our client. This is a client and it is requesting server. It is requesting server. Then it will be having some IP address. Okay. What is done is IP hashing is a hashing technique is being used and a hash is generated of this IP address. A hash is generated of this IP address. Less the hash generated is it can be ABC1. This is the hash, or I can write it in capitals. ABC1. This is the hash. What the load balancer will do? What the load balancer will do? Or I can copy this one again here in our scenario. Suppose we have server A here. I load balancer will forward this request to server A. Let's load balancer forwarded this request to server A, and then A. This the server A responded and client is satisfied with the response. But client raised another request with same IP address, with same IP address. Then what will happen in this scenario? Actually, this hashing is done inside load balancer itself. Uh, okay. So what will happen? What will happen? Then the hash will be generated of this IP address, and since we are using the same hashing technique, then the same hash will be generated, and load balancer will check. Load balancer will check previously to what server I forwarded this hash request. It will see that I have forwarded this hash required ABC1 to server A, and then this request will again be forwarded to server A. So whatever times the client requests the server with the same IP address, the request will each time be forwarded to server A or the same server. So in whatever scenario we require that a request should be forwarded to same server each time, we use IP hashing algorithm there. We use IP hashing algorithm there. Okay, so these were the three static algorithms. These were the three load balancing static algorithms. First one was round robin, then we had weighted round robin, then we had IP hashing. Then we had IP hashing. Let's discuss about dynamic algorithms. Let's discuss about dynamic algorithms. Paste it out here. And yep, good to go. I'm writing the dynamic algorithm. First dynamic algorithm is least connection. Least connection. Then then we have something called weighted least connection. Then we have something called least response time. Then we have another algorithm which is resource based. Which is resource based. Let's discuss about least connection one. Let's discuss about least connection. Least connection here. As the name suggests, least connection, least. So what load balancer does with this algorithm is whatever server has the least number of connections as of now, it will forward the newly coming request to that server. To that server. Let me copy paste the same scenario here. Suppose at an instance, server A is having four connections, server B is having six connections, and server C is having two connections, and a new request is being arrived. A new request is being arrived. New request is being arrived. So what load balancer will they? Load balancer internally maintains a data structure which stores the current connection list, connection numbers of all the available servers. Available servers. Uh, it will check among all the available systems, and it will see that server C is having the least number of connections, and then it will forward this incoming request to server 2. It will forward this request to 2. So this is least connection is whatever server is having the least number of connection. Now at this instance only, load balancer will forward the newly incoming request to that server only. This is least connection, nothing new. Okay, why is it dynamic? Yeah, why we have kept it in the uh, what we say in a list of dynamic algorithms, which because it is dynamic in nature. It is dynamic in nature. The Based on the dynamic nature of these servers, based on the active connections of these servers, this request may be forwarded to any of the server. But in static, what we had was, if we have request four, then it will have to reach to server A in any scenario, whether A is occupied, whether A is already having multiple processes in queue. Still, the fourth request will be forwarded to server A. It's static in nature. It's static in nature. Same in weighted round robin. The fifth request will be forwarded to server B. Same in IP hashing. If request is coming from a particular IP address, then it will be forwarded to a particular server, no matter if that server is having how many connections. So these three were the static algorithms. But least connection is dynamic. It dynamically checks the active connections on the servers and then forward the incoming request smartly. It was least connection. Then we have weighted least connection. Weighted least connection. I have to write it with black. Weighted least connection. We have weighted least connection. What happens this time is, in weighted least connection, what we do, we assign weights to a server. We assign weights to a server. Let's discuss the same scenario as we discussed in weighted round robin. This one. Suppose server A has 16 cores, server B has 8 cores, server C has 4 cores. And now this time signifies a active connection on the servers. Suppose server A currently has 8 active connections, server B currently has 5 active connections, and server C might have 2 active connections. If we go as per the least connection algorithm, we may see that server C is having the least number of connections, that is 2. So the newly incoming request should be forwarded to server C. But if we see the capability of server C, these are the here we have only 4 cores. So it might happen that these two active connections are already a used workload for server C. And it might happen that these 8 active connections are not that used workload for server A. So again, what we do, we assign a weight to each of the server. Suppose it we assign weight 4, we assign weight 2 to this server, and we assign weight what 1 to this server. Now we have a formula. We have a formula for this that says forward the incoming request to the server. Whatever we have is, here we have number of active connections and divided by weight. divided by weight. Divided by weight. What whatever server has this as the least ratio, then the newly incoming request will be forwarded to that server only. In this scenario, we see it has eight active connections. It has eight active connections. So its ratio is 2:1. That is two only. Its ratio is 2.5, and its ratio is 2. So what does this signify? What does this signify? Server B had five active connections. Server A had two active connections. It seems that server A had eight connections, that is a larger workload than server B. But this result tells us that server B is having a larger workload than server B, server A. So the newly incoming request will be forwarded to either server A or server C. It might be whatever we have the algorithm, it might be on the basis of round robin or whatever, but it will be forwarded to either server A or server C or server C. So this was weighted least connection algorithm. This is weighted least connection algorithm. Then we have third one, that is least response time. That is least response time. This is least response time, and as the name signifies, it forwards the request to the server which is having the least response time. How? Let's copy this one only. Suppose this server has a response time of 100 milliseconds. This one is having of 80 milliseconds, and this one is having 25 milliseconds. So the incoming request will be forwarded to server C because it has least response time. Now you will ask me how the response time will be calculated. I would say that load balancer is smart enough. The response time is what? The time at which it forwarded the requested, and the difference, sorry, the difference of time the request was forwarded to server and the response was received from it is the response time. Is the response time. So whatever server is having the least response time, the incoming request will be forwarded to that one only. Okay, this is least response time. Then we have our fourth one, that is resource based. That is resource based. What happens in resource based algorithm is that we have something called event. We have something called event. Event keep scanning the servers and event keep scanning the servers and keep notifying the load balancer about the available resources, about the available resources. So whatever server is having the highest number of resources available at any instance, the newly incoming request will be forwarded to that one only. That one only. This is resource based dynamic load balancing algorithm. This is resource based dynamic load balancing algorithm. Okay, now we are done with our algorithm. Now let us quickly discuss about the type of algorithm, types of types of load balancers. Types of load balancers. Types of load balancers. So we generally have two types of load balancers. First one we have is uh, L4 load balancer. L4 load balancer. Then we have another one which is L7 load balancer. This is L7 load balancer. Now you will ask me what does these numbers 4 and 7 signify. I'll say in a networking we have OSI models, right? We have OSI models. So the fourth layer of OSI model is what? Transport layer. What is the seventh layer of OSI model? That is physical layer. So L4 load balancer works as the transport layer, while the L7 load balancer works at the physical layer. Now you will ask me, what does it mean? Working at the transport layer or working at the physical layer? So Let's discuss this. At transport layer, what it does, it it just considers let's discuss about L4 load balancer first. L4 load balancers. It considers, or I can say it routes, load balancer routes traffic on the basis of IP address, port, protocol, and it does it without inspecting the application data. Let's take an example of this. Client is requesting to a endpoint that is get. This is a get method and it is somewhere to v1 slash products. Okay. Or let's simply write it products. Okay. It is coming from some IP address. It should be coming from some IP address. Let's write it localhost as of now. But there should be some, uh, what we say, client IP address. Then there should be some server IP address and whatever. Yeah, we shall be having some port, whatever, and this together known as socket address, IP address, and port. So what load balancer does is load balancer just will this there can be a we added protocol here. Then there can be a protocol as well. Suppose it is a reliable connection, so protocol is TCP. So what L4 load balancer will do, it will only see the client IP address, server IP address, its port and TCP, and on the basis of this, it will redirect the request to the appropriate server. It will not see what the endpoint is and what are other application data. Okay. Now now comes another type of load balancer, that is L7 or layer 7 load balancer. It is layer 7 load balancer. let's discuss it routes traffic based on application level data. It routes traffic based on application level data. It routes the traffic based on application level data. What it checks in ST level, like what are the protocols we use? We use HTTP or HTTPS. Let's understand this using an example. Suppose it is suppose we are having the same endpoint, that is get slash products. Here we are having, this is the endpoint, and it is using protocol as what? HTTP, oh, 1.1.1, sorry, HTTP 1.1. Okay, then let's suppose this is host. Since this is some e-commerce related stuff, we can have something like www.shop.com. Okay, so what it will do now? What it will do? It will redirect this endpoint to the product related service. It will redirect this to the product related service. Suppose we had some another endpoint, that is slash cart, then it will redirect it to carts later service. We have login. It will it will forward it to authentication related service. So this is L7 load balancer. Is L7 load balancer checks these application level data and forwards requests based on it, while L4 or level 4 load balancer only checks the IP address, port, and other transport layer related stuff and forwards the incoming request based on it. Based on it. So it was all in the lecture today. We discussed about load balancing, why load balancing is required, what are the benefits of load balancing. When then we discussed load balancing algorithms, static algorithms, dynamic algorithms. We had a discussion around round robin, weighted round robin, IP hashing, and static algorithms. Then we discussed about least connection, weighted least connection, least response time, and resource based in dynamic algorithms. And at last, we had a discussion around types of load balancer. First one was L4 load balancer, and another one was L7 load balancer. So it was all for this video. In the upcoming video, we shall be implementing our own load balancer using Nginx or Elastic Load Balancer by AWS. So keep tuning. We shall meet you in the next set of lectures. Until then, keep learning, keep exploring. I'm signing off. Thank you.